Saxon Algebra 2, Lesson 77. Greetings, students. Today, our topic is just some straight up algebra. Nothing fancy, a little drama, but you know, that's what happens when you're smart and you're in Algebra 2 and you're halfway through the year. You just are going to get some advanced stuff. Let me just jump in. John puts a bunch of paragraphs at the front. I think that's so unhelpful. It's so much better just to dive in. All right, ready? When you see this, you're going to be like, what in the world? Solve, our instructions say. I know, that's hideous, isn't it? She sounds hideous. Verizon commercial. Verizon? No, State Farm. But they wear the same color clothes, right? They wear the red shirts and the khaki. You know the commercial I'm talking about. Please tell me you do. If you don't, then you need to pause this and immediately Google State Farm, she sounds hideous. Find the commercial on YouTube and watch it. I'm serious. Right now. Do it. Okay, if you're back, then I'm assuming you watch that commercial and you know what I'm talking about. She sounds hideous. Okay, what we need to do here is isolate the radical. Jesus was a radical, and he got isolated on a cross, didn't he? I mean, you know, there were other guys with him, but he was on his own cross, so I think technically he was isolated. Okay, what that means is that we have to kick these little pups over to the other side. Goodbye, goodbye. And now we just have this evil torture device. It's really just a pig house with some happy pigs inside. Equals x plus 2. Okay. Now we are ready to reverse the root. And what I mean by that is we want to get rid of this pig house. So what we do is we cube it to offset it, right? The opposite of taking the square root, well, this isn't a square root. The opposite of taking a root is raising it to a power. So this told us to take a cube root, so we're raising it to the third power. This now cancels. And we have a very reasonable and orderly looking left-hand side, right? It went from nightmare to I'm fine with it. But look what we have to do over here. And spoilers, this does not mean x cubed plus 8. Oh, no, 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 no. We have to cube the binomial. So what we have to do is first multiply this. This is squaring the binomial, right? We're at the dance, we do x squared because we're multiplying. We do 2x, she sits down, she stands up. 2 times x is another 2x plus 4. Okay, that creates a very orderly, I think they were waltzing. I'm feeling like this is a waltzed trinomial. But that's only 2, and we need to do it 3 times. Okay. This just adds insult to injury. We're dancing again. X cubed plus 4x squared plus 4x. Sit down. Thank you. She curtsies. You're welcome. Now it's her turn. She stands up. 2x squared. Check your columns. It should all work out. Plus 8x plus 8. Oh, I ran out of paper just at the right time, didn't I? So this becomes, I'm going to add it, but write it over here because I don't need to write it 85 times. X cubed plus 6x squared plus 12x plus 8, right? X cubed plus 6x squared plus 12x plus 8. Now I have a lot of monstrous creations. But look what happens. The first thing I'm going to do is say, look, we can just wipe out the x cubed. We have x cubed on both sides. So when we subtract, they both eliminate. And now look what happens. When we subtract out our 6x squareds, they both eliminate. Which means this just went from chaotic and evil to darn cute. Whoops, I forgot the x. Do you see what I'm saying? This is adorable. What are we even talking about? Subtract 8 from both sides. Minus 12 equals 12x. Goodbye. I gasped. I literally gasped. Minus 1. After all of this drama, it boils down to x equals minus 1. Now, the only sad news I have for you is that in this kind of problem where we're powering up to eliminate a radical, we can create what are called spurious roots. Beware. The spurious roots. I mean, that's good advice, don't you think? Just in general. Beware the spurious roots in life. Spurious, I think of as kind of like false positives. And the way that we do that is we have to check our answer. I am not a fan of checking answers, but fine, we'll do it. So what we have to do is we have to take our proposed solution of minus 1 and we have to plug it back into that. Are you kidding me right now? All right, I'm going to flip my page and do it over here. Ready? It was this. Okay, so it's negative 1 cubed plus 6 times negative 1 squared minus 4, and then minus x minus 2 equals 0. We have to check that. See how I just plugged the minus 1s in for the x's? Oh, wait. Okay, that's a minus with a minus 1. All right, let's do this business first. Minus 1 times minus 1 times minus 1 is, guess what? Minus 1. Minus 1 squared is positive 1, so this just becomes plus 6 minus 4. So this becomes cube root of, that's minus 5 plus 6, that's positive 1. Then, so I've simplified this. Now I'm bringing down the rest of the problem. Plus 1 minus 2 equals 0. The cube root of 1 is 1. 1 plus 1 minus 2 equals 0. That's true, right? Because 1 plus 1 is 2 minus 2. 0 equals 0. That's also true. Yay, we got it right. Okay, we're only doing one of those. I think one's plenty, don't you? The other two problems are slightly different, also advanced radicals, slightly different challenge though. Solve. Oh boy, this one I've put on a bunch of tests. I don't know what the timing was like, but I often do this one at midterm time. K minus 5 square root of minus square root of k plus 1 equals 0. Okay, that's right. All right, now what we see here is that isolating the radical is not that easy because we have two radicals. So here's what we do. We isolate the ugliest radical. Okay, that's how we tweak the rule for this situation. This is uglier than this. So I'm going to add and subtract. I'm going to kick those two to the other side, right? That eliminates, that eliminates. So now we have square root of k minus 5 equals square root of k minus 1. Now, we follow the same steps. We still have to reverse the root, right? And we do that by squaring. This one doesn't have a number, so we know it's a square root, so we square it. Now we have to do the same thing. We have to square that. Oh, what? Okay, this turns out cute, so let's just look at that for a minute and feel happy with our lives. Now we have to take these kids to the dance. All right, square root of k times square root of k. Okay, that equals k. Cute. Minus square root of k. Sit down, thank you. Your turn. Minus square root of k plus 1. So I'm adding this, but I'm writing my answer up here so I don't have to recopy it. It's k minus 2 square root of k plus 1. All right. That seems reasonable. Now look what's going to happen. When we subtract our k's, they're both going to go away. So that's taken care of. Let's swim the 1 over here to join this guy. Oops, not 5, 1. Right? That cancels. Minus 6 equals minus 2 times the square root of k. Divide by minus 2. So the square root of k, I'm flipping him over to this side now, equals 3. And so now we just have to square one more time, and we get k equals 9. Huh. That was kind of interesting, right? Let's check again. All right, so I'm going to take my solution and my original expression. I'm going to go to the next page, and I'm going to take it for a spin and see if it flies. I mean, is that a mixed metaphor? I think maybe so, but just play along. All right, 9, right? We said x equals 9? Oh, it was k, sorry. All right, alphabet soup here. All right, the square root of 9 minus 5 equals... No, minus the square root of 9 plus 1 equals 0. And 9 minus 5 is 4. So square root of 4 minus square root of 9 plus 1. I didn't simplify that very much. 2 minus 3 plus 1 equals 0. 2 minus 3 is negative 1 plus 1. 0 equals 0. It worked. Yay. Okay, so this answer checks. Ka-ching. And this one checked too. Okay, so whenever we're doing these isolate the radical things, we have to check your answer. Answer's a weird word, isn't it? What's that W doing in there? Oh, English. Okay, so we're checking our answer. I think we have one more. We do. I think John needs to give us one where it doesn't work. I mean, maybe that's a spoiler, but I feel like we need to see that playing out. Here we go. Solve square root of x minus 8 plus square root of x equals 2. Now, I'll be the first to say, you guys, this is the way it was written in the book. If you want, as you're doing your homework, you can fix it, right? You can do this. Oh, no, I want that over there, so I'm going to do minus square root of x plus 2, right? You can copy it. I just do it so that you can see every little step. I don't want to ruin any of the fun for you. All right, here we go. Square it. Square it. X minus 8, that's cute. It goes from the left side is the headache and the right side looks fine to the right side looks fine and the left side becomes the headache. Here comes the headache. We have to multiply that wretched little monkey. This. Minus square root of x plus 2 times minus square root of x plus 2. Okay, we're multiplying these two first. We're going to get just a plain x, and it's going to be positive. minus 2 square root of x. Thank you, goodbye. Her turn. Minus 2 square root of x plus 4. I add and I write my answer here. X minus 4 square root of x plus 4. Now I subtract x from both sides. It mercifully cancels. And then I'm going to subtract the 4 to swim it over here. Goodbye, goodbye, goodbye. Minus 12 equals negative 4 times the square root of x. Divide by minus 4. And we get square root of x equals 3. So x equals 9, right? We just square it to eliminate that last set of roots. All right, this is the same answer we got last time, isn't it? Yeah, okay, we got 9. So now we're going to check. And I like to see this in your homework or on a test. I want you to write check so that I can see, oh, here's where you're checking your work, right? Otherwise, it just looks like the problem's carrying on. Here we go. That's the original problem. 9 minus 8 plus the square root of 9 equals 2. 9 minus 8 is 1. So that's square root of 1. So that's 1 plus 3 equals 2. Uh-oh. 4 equals 2. No, that is a fail. So this one, this is how I would show it. I would box it, then I would cross it out, and then I would write empty set. No, that's the null set. That's the empty set. Or no solution. That is the final analysis of this problem. All right, so show the answer, cross it out, and then say, nope, sorry, no bueno. Guess what? That's the end of lesson 77. Wasn't that an algebraic treat? Oh my gosh. Next time we're going to do some really cool and fun force vectors. So get excited. 78 is going to be a polar vector dream come true. Okay, goodbye.